talking about functions. We wrote a function to compute the correlation, isn't it? The Spearman's one, you needed the ranks. The ranks are like ordering, right? Okay, but it gives you the position, not the order of the data. So we've seen part of it, which is rank. So I can add ranking. So it's ranking, sorting, and ordering, right? In R. Okay. So we've seen the ranks where you just give the command ranks, and then it gives the ranks of the item. So first of all, let's just generate some data sample. Okay. So for us to get some random sample, what function do we use? We use sample, right? Okay. So sample, let me just, for the sake of those who may not have seen, so generate random sample. So to generate a random sample, we use the function sample. So let's do question mark of sample. There it is. So what does it say? It says random samples and what? Permutations. Good. So we come here and see how the function will be. We can copy this. So if you move down, it will tell you each argument. So X is either a vector of one or more what? Elements. So we need a vector over there. N is a positive number. That's a number of items to choose from, right? Okay, then the size is also non-negative. That's the number that you want, right? Okay, and then replace. You remember sampling with replacement and sampling without replacement. Okay, so replace is a logical argument. When it is true, it means we are doing sampling with what? With replacement. When it is false, it means we are doing sampling without replacement. Is that okay? Now, for any situation that you are faced with, nobody will come and tell you that do sampling with replacement or do sampling without replacement. It is up to you to deduce that this situation calls for this. Okay. So, as an example, we want to go and interview people, okay, on their preference for life insurance. Okay. So this is, let's say, level 400 students at University of Ghana. I can go to registry and get a list of level 400 students. Or if it is this department, I can go to the general office. They will give me a list of level 400 students. That list becomes what? If you are holding that list, what do we call it? Is that a population? There's a term for it. It's a sampling frame. Is that okay? Because that's where we are. Yes, you can have the population and so forth. But this is a sampling frame. That's what is guiding you to now go and choose from. So that's the sampling frame. Now, you won't take the sampling frame and be going around the classrooms and the halls to look for them. If you want to select 10 people, what would you have to do? You have the list of students, all the students of level 400 students in this department. You want to interview 10 of them. What are you going to do? You do what? You select randomly. How? How are you going to select randomly? Without? In the first place, will it be with replacement or without replacement? Without. Good. Without replacement, because if it is with replacement, then it is possible that you select one person more than twice. If you interview the person, you get the same opinion. That's not what you're after. So this should be all sampling without replacement. Okay. Now the question is, how do we do the sampling practically? You call them
Randomly.
How are you going to do the randomly? You number them. Good. Okay. How are you going to select the number 5? Yes. Do you get a question that I'm asking? Yes. So you can use. Good. Okay. So what we are going to do is like that situation. Let's say there's they say go to let's say Asin Fosu. Go and interview people in households. You cannot take a batch from here to Asin Fosu. Go and stand there, and then you say you are doing sampling. That's not what goes on. Before you go there, you would have selected the households you are going to. Otherwise, you spend a month in Asin Fosu going around and numbering each house before you do your sampling. So sampling is actually done in the office before you go. Is that okay? So please take note of all this. We are training you. They say we don't train you practically. We do. Okay, but I mean, so what do? You have to get, if it is Asin Fosu, get a list of all households in Asin Fosu. Where do you get it? You can go to Statistical Service. We did what? The Population and Housing Census. So you get a frame. That frame is what? The list of all households in Asin Fosu. Is that okay? Out of that frame, you can now randomly sample. How do you randomly sample? You can number all of them, like he said. And then you can then use R or even your calculator. Okay, through the random sampling and do it. So what we are doing is like that. Okay. So let's say in this, so I copy this, just copy that, the sample X and so and bring it here. Okay. So X, if I have numbered the number of level 400 students and they are, let's say, 600, then remember I'll just write 1 to 600 over here. This alone, if I run it, will generate 1, 2, 3, 4, 5, 6 up to all 600. Okay. Then how many students do I want to interview? 10. So I put 10 over there. Should I replace the student? So it's false, isn't it? Good. Okay, this probe, you remember frequency table? Frequency table. Is everybody okay? Frequencies. Okay, so if let's say I'm collecting your ages, I'll have maybe more than 2 people having a 20. Then it means I have the number of students who are 20 divided by the total number of students will give me the probability or the frequency, relative frequency. That can be used in sampling. In other words, I'm not going to list 20 10 times. I can list 20 once, but give it the probability that it is 10 over, let's say, 30. Which means the other numbers will be 20 over 30. Is that okay? So that's the way of doing it. In R, you don't list things repeatedly because we can just use, let's say, replicate at that moment. So the thing about what we are doing is that it brings to fore whatever you've done, whether you really understand it. Because in order to program anything, you must really understand what the basis. Other than that, you can't. Okay, so that's why I'm going round in circles to tackle problems that we know from the programming point of view. Okay, so this is okay. We don't need to, because every one of them has an equal chance. 1 to 600. We are giving every individual, because each number 1 represents a particular level 400 student. Number 2 is another student. Number 3 may be a female. Number 4 may be a male, and so forth. So let's do it. Let's run it. So if I were to choose people, my first person is what? The person on the 98. Number 98. The next one is 458. The next one is 172. Please call your numbers for me. Okay, over here. You see, we are getting what? Different. But that's what we mean by what? Random sampling. Is that okay? So if he is to select 10 people, his own may be different from mine. It is possible that some may what? Be the same. The numbers may be the same also. Okay, so that's random sampling. So now we know how to do it. So, okay. But our main topic is to now be able to rank them, right? Okay, we saw rank the last time. So ranking will just give us, we use rank. Yes. Yes, I'm recording. So rank data. So when we rank the data, it is going to check what is the position of what? 98. Is it the smallest one? If it's the smallest one, it will give it 1. If it's the second smallest one, 2, and so forth. So that's what we mean by rank. Okay. So when we look over here, the smallest value is in the what? The 9th position, which is 2, which is 1. Yours will be different from mine because we got different results. So that's what we mean by ranking. And this is what we use in the Spearman's rank correlation. Is everybody okay with this? Is everybody okay? Good, okay. Next, we can do sorting. So what about sorting? We use sort, which means we can sort either in ascending or what? Descending order. So sorting is what? Sorting or what? Ordering vectors. Okay. So when you sort, you use this X. Decreasing is what? Is false by default. So what does that mean? If decreasing is false, then when we sort, what are we going to see? It will be increasing. So let's see. Data. So Elizabeth, 2, 69, 98, 17, and so forth. Please, have you seen the difference between these? Okay. Yes. Yes, you can. Yeah. Okay. Then, look at this too. For ordering along more than one variable, example for sorting data frame, see order. So order is different from sorting. The principle is the same, but not really. There's some differences. Okay. So did we? I think we created some data frames. Do we have? Please check your whether our data frame had what do we call it? A quantitative variable like age, weight, and so on. We created a data frame and matrices earlier. What we are going to do is to be able to sort, let's say, arrange them in order based on age. Do you get what I'm saying? So we have a data set on your weight, on your religion, and so forth. But I want to make it in such a way that the youngest one comes at the top, and so forth. So that's how we do it. Okay, so please let's go back. I think I have deleted mine, but I can go back and create it. Let's go back to when we started with the data structures. We should have some so this one, age, weight, yes, so let's do that again. Age, height, religion, weight. And then we use a data frame to, yes, over here, DF data. So if you go back to the DF data, if you don't have it, you can go to Sakai and copy. Is that okay? Okay, so this is it. DF data is like this. So age of the person, weight of the person, religion, and so forth. What we want to do is to be able to arrange it such that the youngest one is what? 18, right? So that person will come first, row 1, then 20 will come, 21, 23, and then 28. That's what we mean by ordering. That's where you use ordering, not sort to do it. If we are sorting just a vector, we can use sort. But if it is what we want to do, you know, in Excel, we would have done this. If Excel, we will say sort this one. That's what we are trying to do. Please, are you looking at that? You can sort from smallest to what? The largest, or largest to what? The smallest. But when you do that, it will ask you to expand. That's what we are doing in now. Is that okay? So here, let me choose one of them and do this. So for example, I want to use the attendance, right? So what I'm going to do is that I want to rank attendance. So what do? I go to home, I go to rank from the smallest to the largest. I should have selected, yes. So you see, it shows me this arrow to show that it is what? It has been arranged in order. Okay. We could have used this one as well. So it's now smallest to, I can do largest to what? Smallest. But in every case, what does it do? It rearranges what? The entire document. Is everybody okay with this? That's the same thing we are trying to do in R. Okay. Any question on this before I move on to R? Okay. So now let's see what we will do. So our data is called DF data. So ordering. So what I will do is I will call DF data. Then I put this, what do we call it? The square bracket. Okay. Remember that in the square bracket, because this is two-dimensional, we need a comma. But what I'm going to do is that I want to order the first age. So I'll order age to select it. Okay. So what I'll do is that the rows, I'll say order. And then what do I want to order? The same DF data. What do we want to order? Age. Okay. Remember, did I talk about order here? You can click over here. Order to, you can order either in ascending or what? Yes. So decreasing is what? Is false. Which means it will order it in what? In increasing format. If you want to go through the Excel one, remember we have largest to smallest and what? Smallest to largest. Okay. So let's do this. So Yes.
So, like, what are the difference between the sorting and the order?
That's what I'm saying. That the sorting will take a vector and arrange it either in increasing order or decreasing order. The ordering will also order in either increasing or decreasing order, but with respect to one specific vector. So look at what is happening now. You see, age is in order, but no weight, because it will carry your age along with all your other data set, and that may not necessarily be in order. I can also order according to the weight. So that's it. I can change this to weight, and the whole thing will change. I order now according to what? Weight. Do you get what is happening? So now you see the weight has been ordered. The first one we arrange according to your age. The next one we did according. So you can arrange according to any one. So that's the difference. Any question on this? Any question on this? Okay. So you should be in a position to do some of these things as we move on. Next. Next is the apply family of functions. Okay, so here it is actually for. Okay, so let's go back here. In some cases, when you have a data set, you may want to get some measures on either rows or columns. Okay. Now, so what it means is that, let's say I have individuals, I want to find the averages of all the variables. Okay, so for example, I want to know the average age. I want to know the average weight and so on. Then it's like you are applying the same function to each column. Is that okay? Or it may be the individuals like this, and I want to find maybe the highest value weight for an individual. So when you have a problem like that, you can resort to what we call the applied family. There are so many of them. I won't have time to teach you all. So I introduce you to the basics, and then you can build upon it. So there are so many of them. The first one is apply. We will talk about it. There is also S apply. There is also L apply. You can have T apply. There is even par L and a whole. So as I said, I won't be able to do all those. I'll just maybe touch on the first one, and possibly I'll use some S apply maybe later on. But you should take note of some of this. So now let's see. Okay. Now if we look at our DF data, there's religion over there. So if I can do it. If we get an error, you can tell me. So now they apply. Let's look at the help function for apply. Okay. So I apply functions over array margins. Okay. So basically, you have the usage is apply X margin function simply for a whole lot. But for me, you need just the three first arguments are okay for you to move on. So it's like this. The usage is applied like this. Okay. So let's say my X is an array. So I want DF data. Okay. Then the margin, it takes the number 1 or 2. When it is 1, there it is. So if you come here, it shows you that 1 or 2. 1 indicates rows. So if I want to do something row-wise, I'll indicate it as 1. If I want to do it column-wise, I'll indicate it as 2. So in this case, I want 2. So for each of them, what do I want to do? My function is called mean. So I want mean like this. So let's see what happens. So it returns NA. Okay. You know why? Who can tell me why I'm getting NA? I want to find the mean of the data frame. Column wise. So I want to find the mean of age. I want to find the mean of weight. I want to find the mean of height and the mean of relation. Why was I getting NA? Because relation is what? It's a qualitative variable. I can't be finding the average of a Christian and traditionalist. What do I get? Is that okay? So we get what? An 80s. Okay. So R gives us NA. So these are some of the things you may encounter. That's why I take my time to teach you data structures. It is very important. Other than that, you will mess up with so many things as you move on. Okay, so that's it. So you see, now it calculates the mean of everything. We can even do summary. Do you remember summary?
Yeah.
It will give us all minimum. And you remember describe. Okay, so we can even pass a function. I can write a whole function and pass it within that function, and it will calculate everything. So it takes every column and does that. Okay, so I can come to look for psych, take it, and then I can come back and use or describe. Good. Now this is going to give us so many arguments. So you see, age, it gets us the variance, the mean. You even use this function, and then you what do we call it? You fix it. Okay, fix in what you did by what we did last week. When you modify an existing function, I mean, in our studio, well, it's okay. Another way to look at it, if you have a function and you want to what do you call it, modify it, you can use the function fix. That's all. That was way back. I haven't used it for like 10 years, but it used to be fixed, and then you go in and do. Once you press enter, it will now override what you have inside. Remember, the one we are using, you need to do it and rerun it. Another way is to use fix. It just occurred to me that I used to use it 10 years ago. Is it 2014? No, 11 years ago. That was 2013. Some of you were at all KG. KG. 11 years ago, where were you? Where? Oh, no. It can't be JHS1. Yes, any question? So that's how you, if you want row-wise, what do you have to do? The margin should be what? 1. Is that okay? All right. We can take a look at it, but in this case, row-wise doesn't make sense. Why is it so? You cannot be adding age and weight and finding their mean. What is that? Because they have what? Different units. You cannot be adding years to what? Kilograms. Do you know what I'm saying? Yeah, and so whatever we are doing is just for the fun of it.
Okay.
Yes.
about the logistic.
Yes.
That
Yes.
I was thinking that you see the Wi-Fi that contains a lot of values.
Yes.
Therefore, we can add all of them with one single value and draw a combination like a normal regression.
You add them.
You add the values.
The one means you have left. So actually it is under the nominal scale. So you can't be computing averages of those ones and zeros, yeah. Any question? So that's it with those things. I can use the same air supply concept to do it. I have a video on this, so I won't waste time here. What did I say in the... Yeah, generating random variables and Monte Carlo methods. So how to generate random variables. That's what we will tail into Monte Carlo methods. Okay. So, first of all, every distribution we have in R, when you do any distribution, I have hurt myself. So every distribution, we're going to get a D for density, a P for F, an R for random, and then Q for quantile. So quantile, random observations, then this is your F, and this is density. Of course, it can be all PMF as well. So when we want to use exponential, we can do RSEP. Let's do the question mark of it. Please keep quiet and listen. I won't have the time to go over it because it's time anyway. And I'm not coming back to it next week or tomorrow. Okay, can we move on? Now look at it. Okay. So D, if we go down, it means that if we want to get the density, we can compute densities. Just like you are doing you did in 221, 224, 112, and so forth. We can do all those things in now. Okay. Then we can get the F, PDF. So the PDF, F, your CDF is this one. Then the Q is the quantile, like I have said. So you see the quantile, you need the P, right? That value over there. And then if we want random observations, we do this. So I'm going to generate 100 random variables from the exponential. When I finish, we'll use that function to also generate, to let you know that we can either use this or we can use our inverse probability transform to do it. Okay, so let's do it. Data.esv, let's say our exponential data. What is here is that we need what? You can copy from here is R, which is random number generation. How many do we want to generate? 100. What is the rate? Remember your mean and the rate for the for the exponential distribution. So let me take, let's say 0.5. 0.5, then the mean will be what? What is the mean? So the mean will be what? 2. Good. Okay. So let's see. So this data is of this form. To be able to check to see how it will look like, we will do a histogram. Does it look like an exponential distribution? does it look like an exponential distribution? Look at it. We can let's increase the sample size. Increase the sample size to 1,000 and notice the difference. So we have this. Let's increase the sample size to 1,000. Okay. You see that the exponential curve is being done. I can even increase it to 10,000. You see, the more you increase the sample size, the more profound the exponential distribution becomes. Now, let me also go through this exercise. We use 0.5. So someone said that the mean will be what? 2, because the expectation of S is what? 1 over lambda. Okay. So now I want to go back to 10 observations. And then I find the mean. What is the mean? 0.86, right? Okay. Then I increase it to 100. The mean is what? 1.83. I can now increase it to 1,000. Please notice what is going on. 2.02. I can increase it to 10,000. 1.95. So generally, what do you think is going on? As yes, what is the population mean? 1,000. Oh, Jesus. What is the population mean for this distribution? It's 2. Is that okay? Yeah, then we selected 10 observations. Our mean was 0.83. 0.86. We increased it to 100, we got 1.383. To 1,000, it got to 2.02. To 10,000, it got to... So we can increase this until such a time that it becomes very close to what? You see this? This is what? 1 million. So which one is closer to the population? When the sample size is what? 1 million. And what are we demonstrating here? As we increase the sample size, the estimate and now approaches the population parameter. What are we? Yes. It is what? It's a law of large numbers. Is that okay? So, and this has so many applications. It's not central limit theory. Not yet. But we should be able to demonstrate central limit theory in this exercise as well. Is everybody okay? Is everybody okay? Lastly, now write a function to generate observations generate exponential random variables from a uniform. Okay, the quantile function is there. So we need to now do that. So let's say QSP is our quantile function. So you need a function, as I said, what do you need? You need the sample size, you need the lambda. Remember that even with the exponential, we put in what? A rate, which is a lambda. Yes. Okay, then you can leave. Okay, thank you. Okay, so I'll just do this, but of course I'll make the video available. Okay. So all you have to do is that you have that over there, right? So it is negative 1 over what? Lambda. Then we multiply it by what? The log of what? 1 minus... okay. Let me just put it in brackets so that people don't get confused. So what I need to do is to generate the P, and the P will be R unif. So that's uniform. So I must give a comment, generate random variates from the uniform, from standard uniform. Okay. So what would that be? That will be I unif just n that I put in. Okay. Then now I can now get my QP is just the assignment statement. Then you have negative lambda of the log what? 1 minus what? P. That's it. And then what do? I return QP. So that will be exponential quantiles as well. So I can put this in brackets, do this. Okay. So now there's no error. So I can just try this and see. We generated observations from where? N was equal to 10. Lambda is what? Lambda was 0.5. Okay, so I can do that. That's it. If I want, I will just sim.esv is my data. So I can do the mean over here too for you to see. We go through the same exercise. Maybe I should plot it before I find the mean. Hey, you say you have class. Please go. I'll make the video available so you. Please make sure you sign. Okay, so that's it. The mean is 1.3. Then I change this to 100. You see, now the exponential is coming. I change to 1,000. Do you get it? I can change to the next and so forth. Yeah. So that's it. You can also generate. Yeah. So you were not.